we'll start with pure inductor in AC circuit. So now our circuit has only one inductor component in the circuit. So suppose this is the AC source and this is the inductor. The AC source has a voltage V equal to V naught sine omega t. It means the source is moving with an angular frequency omega. This inductor have a inductance L, right? So therefore the voltage drop across this inductor would be suppose given by epsilon, right? So now when we calculate, as we already know, if the current I is moving due to this AC voltage source, if current I is moving through this inductor, therefore epsilon will be minus L di by dt. That we have already known, right? So here the voltage drop is this epsilon, and here the voltage of the source is this much. So this is the circuit that we get. So now we apply Kirchhoff's law, and when we apply Kirchhoff's law, we can say that the total voltage V plus E is equal to 0 according to Kirchhoff's law. Now when we just substitute it, we can say that V minus L di by dt is equal to 0, or we can also write it as V equal to L di by dt. Now substituting for V, we write it as V naught sine omega t is equal to L di by dt, right? Now you see, actually we have to analyze the current that is moving, but here the current is in differentiation mode. So if I have to take out the current, then I have to integrate it so that it will be getting rid from the differentiation. So just rearrangement, I can write di by dt is V naught by L sine omega t, or di is equal to V naught by L sine omega t dt. Now see, if I have to take out I, then I have to just do integration over di. Integration over di is nothing but I. And in this side, if I do integration, then there is already dt, so sine omega t dt. So this would be the integration of sine omega t dt. So definitely this side we will get integration of di as I, but here we will get V naught by L, this is the constant, and the integration of this, I am just omitting the constant of the integration, and I am just retaining the main part, and this would be minus of cos omega t divided by omega. So this is the integration result. So if you see this, if you just take it out, you can write I is equal to V naught by L minus, or V naught by omega L minus cos omega t, and this also can be written as V naught by omega L sine minus cos theta is sine theta minus pi by 2 is minus cos theta. So that we are writing in the sinusoidal form, because we know that the current would be considered as I equal to, the representation of AC current is I equal to I naught sine omega t. So when we take this representation and we find out the value here, from comparing this two, we can write the peak value of I naught is nothing but V naught by omega L, and you see here the current is actually sine omega t, but here it is sine omega t minus pi by 2. It means that when we compare this is the current that I am getting. This is the current that is coming out of this circuit. But when we are seeing the source voltage, what was the source voltage given? The voltage does not have anything else except omega t in the phase. So the phase is here only omega t or the angle. There is nothing else. But here what we see, omega t minus pi by 2. It means that when we compare the phase of the voltage as well as the current that is coming out. So when we compare, what we see, the current is lagging behind by pi by 2, or it is lesser in the phase than the voltage. So one thing that we have got from comparing this equation and this equation, that is our general representation of current with the current that I am getting. From there we have got what is the peak value. The peak value is V naught by omega L. And what the second thing that we got is the voltage. When we compare voltage and current, these two equation, what we see, the current is lagging behind by 90 degree in this particular circuit. So I can represent in a vector or a phasor diagram. Suppose this is the phasor diagram and this is my source voltage V naught. This is V naught and this is the vector V. This is the angle omega t, which is at the anti-clock direction. But my current is actually 90 degree from this, 90 degree back or 90 degree behind than the voltage. So if this is the voltage, then I can say this is the voltage. So this will be at a 90 degree angle. This is pi by 2. 90 degree from the voltage behind is what is my current I. So this would be my I naught. So this is the phasor diagram for the pure inductor circuit. Now coming to, we have seen this phasor diagram and we have seen that the voltage is leading, current is lagging. We have also seen that I naught is V naught by omega L. So generally we know that current I is equal to voltage by resistance. So this particular quantity which defines current is generally voltage divided by certain type of resistance, right? So this is called the resistance element. And in this case, what we see, that this resistive element or kind of the element which stops the current is given by omega into L. This particular element in the inductor circuit acts as a resistance. So how in resistor there is a resistance, same way omega into L in inductor circuits, they act as a resistive element or they stop the current. This is called the reactance, right? So this reactance, or this is inductive reactance, which is denoted at XL, right? So this XL is given by omega into L. So this is very much like the resistance in the resistors, but whenever we are putting the inductor, we will call this particular equation as I naught equal to V naught by XL, right? This XL is given by, this is the inductive reactance, and this is given by omega, the angular frequency, into the inductance of the inductor. Now this can also be written as another way. If I directly take the frequency, then we can write 2 pi nu. Mu is the frequency, which is omega equal to 2 pi nu into L. So this is the inductive reactance, or this also acts like a kind of resistance to the circuit. So this is a very important concept. The SI unit for reactance is the ohm. Same thing like in resistor we have resistance denoted as the SI unit as ohm. Same way for the inductive reactance it is ohm, and it is given by 2 pi nu into L. It means that if you have a frequency, if you have a AC circuit which has a very high frequency circuit, then this reactance is high. It means that when you have the higher frequency AC circuit, or the voltage frequency is very high, in that case the reactance would be very high, and therefore the current, the peak value of the current would reduce. And therefore this is also a very, very important thing that we'll see how we apply it in the future applications. And therefore this is the analysis of inductor when we are using an inductor in an AC circuit.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.